We're live. Hi, Ted. How are you
Hi.
doing?
Hi, Alicia. I'm doing well. How are you?
Good, thank you. It's so funny. We were like, oh, so we start with a joke, and you were like, oh no, I don't know any jokes. Like, I don't know any
All,
jokes.
all out of jokes. This is a very serious presentation today.
Is it though?
It always is. Yeah.
I
We
think we're
have,
both very passionate about photogrammetry, so yeah, it's gonna
ab-
be a good
abs-
one.
yeah, I couldn't agree more. The reason I'm here is because of photogrammetry. So I love it and I owe a lot to it. So let's share some of that.
Yeah,
I think what we're gonna try to do today is get a little bit more into the sort of the inner workings of photogrammetry, kind of exploring what to do, what not to do. And I
yeah,
have a few examples of sort of what not to do or sort of how to fix, if you will. So I don't want to I don't want to show the best, right? Let's show the reality of this pretty
yeah.
tricky sometimes tool that we're using.
The do's and the don'ts of drone photogrammetry, and I would like for anyone that is maybe like not familiar and maybe like starting to be familiar with drone photogrammetry, kind of like leave this session today and think that, yeah, I kind of like understand a little bit better how to make the most out of 3D scan data to build photogrammetry models. Is it that fair to say?
I think that sums it up.
Perfect.
Let's-
And as always, keep your comments coming. That's the only way that we have to see your questions. So keep your comments coming, and we'll try to address as many questions as possible. Um, so yeah, let's deep dive, Ted.
Yeah, let's jump in. So I made this little agenda for us so we can
Yeah.
have some structure. Not as many slides this time as last time. I'm sure everybody's used to my slides, but we're gonna freestyle it a little bit.
Yeah.
So I wanted to start sort of just with like a general workflow concept, right?
Mhm.
We talk about a few different deliverables in this space. Like we're showing AutoCAD drawings, we're showing point clouds, we're showing 3D meshes. So all of those things they come at different stages. So let's talk a little bit about that. And then let's dive into what makes that possible, which is the inputs, right? We have our images, we have data within our images that are contained in EXIF formats. We have our controls or scale constraints, whatever you want to call them, just something that we can use to reference and geo-reference the whole model afterwards. And then we have
Yeah.
our software. So there's a ton of software today. The examples and sort of the case studies that we're going to go through, I'm going to include Pix4D Mapper, which is one of my all-time favorites. I have a lot of experience with it. Reality capture and context capture, and see how those
Yeah.
differ.
But I want to emphasize Skydio is compatible with most, I would say, with all photogrammetry platforms. We do not push for one in particular. We know and we understand. I think in the photogrammetry space, it's funny. Like there is not one that fits all. So like whatever, just think about what are your needs and requirements, and based on that, make choose whichever software that fits best for your needs. So,
Yeah,
um, yeah, so we
yeah.
are not selling any of the photogrammetry
No,
platforms. Yeah, yeah.
yeah, I mean,
Yeah.
I'm in a pretty lucky position because I'm a professor and I
Yeah.
teach photogrammetry. I have EDU licenses for a lot of these tools, and I need to have them because I need to really explore pretty deeply how they all work in order to teach them. So, not everybody's in that position, but again, photogrammetry. The great thing about it is that it's agnostic to anything
Yeah.
except for just images. As long as we have photos from a camera, doesn't matter what camera, it'll work.
Exactly.
So after we sort of talk about that a little bit, which we already have, let's talk about alignment, which is sort of the first major step. It has to be successful. If this step fails, the rest of it is not going to go well.
And alignment is also called calibration. It's also called area triangulation. Traditionally, in the traditional photogrammetry workflow, that's kind of like the name. So if you see that on different software platforms, alignment, calibration, area
Re-
triangulation, that's the first
Registration
registration.
sometimes, yeah.
Yeah,
There's all these terms, but at the end of the day, all it means is can we figure out where the cameras were or
yeah,
where the drone or the camera was when it took that picture.
yeah. So you
Yeah.
have the metadata will bring like that kind of like reference, and then the first step is calibrate or reorientate those images to where the real position was.
Yeah, exactly. And the key to
Hmm.
that is overlap. So the ongoing theme, overlap is king. We absolutely need to have lots of images, but then also lots of the similar content in each image. And you know, there's different rules of thumb, if you will, but stitching depends on overlap. And if you don't have the overlap, then none of this will work.
Yeah,
Mhm.
stitching basically. Theodore is saying yes,
Yeah,
stitching
exactly.
basically. Cool. And then finally, georeferencing, scale and
Yeah.
positioning.
Yeah, so this is something also that comes up quite a lot. And, you know, we're
Hmm.
used to doing photogrammetry from the top down and doing surveys and volumetrics and that sort of thing. And in that case, it's not always necessary to do scale or positioning. In a lot of other cases, though, it is. So it's one of those things that you really want to use these tools in georeferencing if you need to have them. Not all are the same. So we'll talk a little bit about how I do it in a few examples as well, especially bridges, which are different.
And we'll talk about, absolute accuracy versus relative accuracy versus precision versus resolution. So I wanna also like go over all these concepts and make sure that we know what we are talking about when we say absolute, relative accuracy, resolution.
Yeah,
Cool.
I'm gonna default to you for that. You're the one that went to school for surveying. I'm all self-taught on this type of stuff.
That
So
was a long time ago. I'm gonna need your help.
all right, so
Cool. Let's
let's
deep
dive
dive.
in. So I made this little slide just to sort of break down the most common sort of workflows that I do. Not everybody's workflow is going to be the same. This is just how I think about it. So at the top here, we have the steps, right? Alignment. We get all our cameras registered with each other using that overlap and nice image. And
Hmm.
then once we've done that, we have something called a sparse cloud. So in the alignment step, when we're done with that, what can this be useful for? Well, you can actually do a lot by just running this first step. You don't have to do these other two steps if you don't need them. So
Yeah.
what I can do with alignment, or what I've used it for in the past, is to determine camera position and orientation, right? And I can take that just position of each camera and I can bring it to something else. And I can also use this step to perfectly scale my model, georeference it, and even just make measurements on the pictures themselves. So
I was
in a
gonna
lot,
say that, yeah, because
yeah.
some software platform like Context Capture and Help Me Here, like I'm sure some others as well, after the calibration, after the error triangulation or the registration, they will allow you actually to do like a quality check and also basic measurements. So they, with the cameras already oriented, they kind of like overlap all the images, so you can check coverage, the quality of that, the overlap, and they also have like basic measurements to do like distances and even volume calculations. So I think that's a very good tool to keep in mind when you are doing like a very complex infrastructure. You want to make sure that, in the field, you're gathering the right data and that you have the right data before you go back to the office.
Yeah, well put. So in terms of measurements, you know, we don't always need to be measuring from a 3D
Yeah.
object, right? We
Yeah.
sometimes we'd like to just quickly measure from a 2D image. So in
Hmm.
order to do that, we first need to triangulate all the cameras, figure out where they are. Once that's done, we can actually just draw a line on each image and get the resulting measurement from that line or an area. So it can be really flexible. So it's a really nice step, and again, it has to be done, but it's nice
Hmm.
that you don't have to do everything, because these two, they take some extra time
Yeah,
generally.
absolutely. Yeah. The alignment will be what is fair to say, like a few minutes for how actually do you know by heart how long did it take for this bridge
No,
model?
so alignment generally is one of the faster steps, and alignment really depends on the data set. For this bridge, I believe the alignment was like an hour, somewhere around there. And different softwares, they take different amounts of time for each step, and they do them a little bit differently too. So we'll talk a little bit
Yeah.
about sort of what's happening there. But there's no rule of thumb. What you can do is you can do really quick alignments in the field and then just check your data, see if it's going to be good enough for you to pack up and go to the office. And that's what I sometimes do. But generally, you're going to want to do the alignment and just sort of let it sit. Could take a while if it's a big data
Yeah,
set. Yeah.
absolutely. Okay, so you have the alignment done. What's
Right.
the next step?
So generally, after we have alignment done, we go to the second step, which I call densify, and it's referred
Mhm.
to as densification a lot of times. So this alignment step gives us our camera positions, but it also gives us a sparse point cloud. So it's like a series of points that sort of resemble our object or whatever we're scanning, but there's not many of them. They're scattered.
And
The
those are the tie points.
Yeah, the automatic tie
Cool, cool.
points,
Yeah.
the tie points that the software picked up on its own.
Yeah.
So they can be useful, but if we want to go into more detailed models, then we need to create more of them. So this
Hmm.
densification step is basically very similar to that alignment step in terms of what the software is doing. It's just doing a lot more of it. And from that result, we generally get what we call a dense point cloud. So that's what we have here. And that cloud can now be used for several other things. I personally think the point clouds are extremely useful. Sometimes I like them better than meshes, which is the third step. But
That's
what
controversial. I didn't know this
you know,
about you.
it really depends. What I love about point clouds is that they're very easy to filter. So what I mean by
That's
that is,
true.
for
Yeah.
example, on this bridge that you see in this
Hmm.
alignment phase, if we don't want this railing to be part of our data in the next steps, we can just take
Hmm.
that out in the dense cloud, and then the preceding steps won't include those points.
So I think again it comes down to what you're trying to do and the applications, the deliverables that like your workflow requires, and then reverse engineer from that. Do you really need a point cloud? Do you really need a 3D mesh? Do you maybe need the two of them? So could you actually tell me what are the different applications? Why do you use the 3D mesh and the point cloud? What are the different applications you use with each of them?
Yeah, so for point clouds, those are useful for measurements and extraction. So
Mm-hmm.
anytime you see
Mm,
our examples where we have the bridge in a 3D model, and then we have
yeah,
the bridge in like a CAD line work BIM model, that was actually extracted from the dense
from the
cloud.
point from the point cloud.
Yeah.
Yeah, that makes sense. So that, and the reason being is because you will be able to pick the points much more easily than with a 3D mesh, correct?
Exactly. There's just so
Yeah.
many more points. There's more precision.
Mm.
The accuracy is the same, but the precision is better in a dense cloud, and that
Okay,
allows us to go from point to point.
hold that thought. Let's actually
Yeah,
start. Yeah.
we'll talk about that a little later too, for sure.
Precision versus accuracy. Okay, cool.
Yeah. So I love point clouds, but a point cloud is a point cloud is a point cloud. So a point cloud created from a laser scanner is essentially the same exact thing as a point cloud created from photogrammetry. It's just how do we
Yeah.
get to that point cloud that differs. Right. So then our last sort of step or deliverable or package, we're going to refer to that as the mesh.
Hmm.
This can be 3D. It could also be 2D in terms of orthomosaics and
Yeah.
DSMs and those things that we see in the surveying side of this industry. But for this example, we're going to be talking about the mesh, the actual triangulated points and the surface and the textures. So the visual information that's coming from the pictures, and it's basically just painted onto that mesh. And those are
Yeah.
two separate components.
And the obviously you can create a mesh also with a, so in 3D scan we have the ability to do 3D capture, so that's the one that will adapt the flight plan to your 3D objects. You can also do a excuse me, you can also do a 2D GPS capture, a 2D capture, which will allow you to generate an orthomosaic, but also a 3D model. You just will miss the information of the any elevated structures. Basically, won't have that information, but still might be good enough. Like for example, for
Hmm.
stockpiling, for volume measurements, is absolutely good enough. So again, we go back to what you need for your project, and I'm gonna be very, very, emphasizing this all the time because I think people tend to just go for everything and they might not need, point cloud, 3D mesh, or some mosaic. So just think about what you need and then reverse engineer from that.
Yeah, I have had people ask me like, "Hey, have you ever used your Skydio for volumetrics and measuring
Mhm.
piles of dirt or whatever it is?" And
Yeah.
absolutely, I have, because it's the same thing. It doesn't really change as long as you have all of these things that we're going to talk about in that input. Then the deliverables are essentially the same.
But the way you actually define that flight plan will massively impact the time
Yeah,
in the field and the time in the office. So for a
huge.
stockpile, for example, I will go for a 2D capture. It's super quick, like in matter of like 4 or 5 minutes, you can capture like hundreds of pictures that are good enough for then like photogrammetry software, create your 3D model, your orthomosaic, do those volume calculations, and that will take you maybe like a couple of hours compared to a 3D capture, which will be first of all longer flying time, and second of all longer processing time. So
Yeah.
it will be it will be like a massive difference between 2D and 3D, and the resulting
Hmm.
accuracy and deliverables will actually be enough.
Yeah.
So yeah,
Absolutely. The capture, especially when we're talking about 3D in terms of structures that have elevation, it's completely more complicated as far as 3D scan completely
yeah,
changes the game for me. But when
yeah,
we talk about orthomosaics, or like you just mentioned, like top down is usually what we think about, but you can also extract orthos off of facades, off of the
yeah,
sides. So in Pix4D, that's called an orthoplane. So a lot of these softwares, as long as you have that dense cloud and you have that picture information, you can extract 2D versions of that ortho from any angle
yeah,
that you like, which is really useful. All
brilliant.
right, so let's keep going. Image quality.
Image
So
quality.
we had these in the first webinar, but we didn't have too much time to go over them. What I wanted to really get across here is that when we are talking about photogrammetry, and generally this photogrammetry that I'm doing it outside. So
Yeah,
there's a ton of photogrammetry that's done inside, and that's really what photogrammetry started. You can control the lighting conditions, you can cross polarize your light, you can do all kinds of fancy tricks outside. It's a different environment completely. So in this example, you can see what I mean by those factors. We have this reflective tile surface here that's way overexposed.
yeah,
Anytime you see just pure white in an image, think of that as just being a void of information. There's
yeah.
nothing really there for us to grab onto in that image.
That's gonna be noise in your final 3D deliverable. Like there is no information. Photogrammetry cannot do magic. So
Yeah.
it's just basically we can't extract, like photogrammetry can't extract information if there is no information on the pixel. So how will
Yeah.
you handle this? How do you handle when, because there's an element of like, okay, fly, in cloudy conditions. Well,
Yeah.
I'm based in California. I can't, like, there's
Yeah.
literally no cloudy days. So how do you handle that, Ted?
You
From an
you re-
image?
Yeah, for that's the age old question. How do you handle cloudy days versus sunny days versus overcast days where the clouds are moving very quickly? Like here today, we were really overcast earlier. It was like
Mm,
pristine photogrammetry conditions for outdoors, and then now the clouds are breaking and the sun is coming in and out of the picture. So there's only so much you can do, but at the end of the day, there's a little bit of planning in the field, regardless of those conditions. So
mm-hmm.
maybe schedule your scans so that they are opposite to the movement of the sun that day. Maybe take some time, some breaks between them to let the sun change its angle, and then maybe the reflection will be more favorable for the area that you're
Yeah.
intending to
And
scan.
also the shadows will be a much, like, the more are minimized, the better. Winter
Hmm.
has longer shadows. Shadows are not good for photogrammetry, although the algorithms have improved massively in the last few years, but like there is still an element of some noise coming from there. So
Hmm.
yeah.
And there's a lot of things you can do after the fact. So I call it pre-processing, but generally in a picture like this, we have a dynamic range that's pretty large. So what I mean by that is that we have really bright areas and then we
Hmm.
have dark areas in the same image. So when we're taking a file from our camera, if it's a JPEG, we can play around with that JPEG. So what we can do is we can turn down the highlights, so those really bright areas, and hopefully extract some more information there, and maybe we can turn up the shadows and extract some more information out of that dark area. The JPEG, though, only gives you so much latitude to do that. So in really tough conditions, especially bridges or really bad days for this, what I usually like to do is shoot in RAW or DNG, which is a much bigger file, and then edit that file because it actually contains some information that you can't see until you bring it out in some software like Lightroom or Capture One, which is just photo editing software.
Would you say this is a more like this is kind of like a best practice for more advanced users? Like I kind of like every time that I hear about pre-processing the images, I'm like, oh, you might actually lose information in that process by
Yeah,
trying to do something.
Yeah, it's really not that advanced, to be honest. If you've ever edited a picture on a Mac or on a PC, and like, pictures from your phone, like it's the same thing. We're just
Okay.
making it look prettier. But for the photogrammetry engine, what that's actually doing is giving it more points where it could sample from and give it some
Okay.
signatures. So
Fair enough.
really,
Yeah.
the ones we're really worried about, to be honest, is the overexposure. The shadows, like you said, they kind of suck, but they're not as bad as just
Mm,
pure lack of information, which is
of
what
course.
there is where there's brightness. So, and because we're moving, we can't really control where that bright area is along all of our pictures. So in this example over here, overcast day, perfect
Hmm.
conditions. Over here, bright day, right? You can see the difference in this image, and you can see how when we're moving and capturing these images, that overlit area or that overexposed area seems to be in the same part of the frame, regardless of which image we're taking.
Yep.
Yeah, so this is generally, we have to deal with it. I'm a big proponent of pre-processing. I think it can make a huge difference, and I've seen it make a huge difference. So
Mm,
if you do want the best results, and we're talking about best practices here, I would recommend it if
okay.
you need.
Fair enough.
All yeah. All right. So let's dive into a little bit of a case study, and we'll talk a little bit deeper about some of these concepts. So this is a facade scan. So it's a little bit different than what I usually do, but in this case, we wanted to create basically a digital copy of what this building's facade state was like. Right. There's going to be some construction next door, and we want to make sure that during that construction process, we have a record of where it was when we started. So what you're seeing here is the scans that were used to construct this. And I chunked it out. Like I talked about last time, it's, I think, really good practice to break things down into smaller, more manageable chunks, and then bring all those things together
Hmm.
later on. So the first chunk was the roof. The second chunk was this elevation on the side, the very long one, lots of images to capture here. And then we did the front of the building and then the back of the building. We didn't have to do the other side conveniently. And I timed this so that I started with the roof when the sun was almost directly above it. Sorry, actually, I started with the front when the sun was facing it, and then I
Yeah.
did the roof, and then I did this main elevation here, this west, or sorry, the south elevation, and then I did this west elevation when the sun was starting to set. So I kind of followed the trajectory of the sun in my planning, and
To
that's why
make sure. Yeah.
yeah, and that's why chunking was so important.
And so, and from a 3D scan point of view, Ted, can you explain me? So you didn't do a 3D capture of the entire building, which is really interesting. So how did you, what are the, did you use a 3D capture of each of the facades and then the ceiling? How did you do this?
Yeah, so you're seeing that here. I basically just took slices of each elevation in the 3D scan. So I set up the pillars just in front of the building, and then just a little bit inside from some sort of looking top down interior to the building. So this is what the working surface started like.
Yep.
And then once that was established, and I was happy with the amount of overlap, especially in here between the two sides that I was going to combine together
So
later.
you use the pillars like kind of like a little bit inside the building to make sure that you had enough overlap in between the facades. Is that
Yeah,
right? Yeah.
exactly. So I essentially, when I was flying the drone, when I was flying the Skydio in that augmented reality view, when I'm dropping the pillars,
Hmm.
I'm flying above the building and just slightly inside and to the right, and then on same thing on the other side of this corner. So
Interesting.
doing what I can to just slice off one facade at a time,
Yeah.
but then also making sure that I have a little bit of overlap between them.
In between them. Hmm.
Yeah, and I actually also had ground control points that we'll talk about in this example as well, which I wanted to make sure that I have at least 3 of those in each slice, so that will help me put everything together
Yeah.
afterwards. Mhm.
We've been talking about doing a 3D scan live from the field, just to show you, well, everyone live how to set up 3D scan for like different use cases. So bridge will be one that I would love to do with you, Ted. But also like building facade will be another one that is on my list. Um,
Mhm.
so yeah, stay
Yeah,
tuned. Stay tuned.
States, yeah, there's lots of examples because so to capture this with a manual drone would have been really challenging. In fact, I did have
Mm,
a manual drone with me that day, and I attempted it. So the thing is that while I was able to capture the data, it wasn't at consistent overlap or at consistent distances from the building.
mm,
So I'm not quite sure about how good that's going to turn out when I process. But with this, I know for sure that the overlap is there, and I know that the ground sampling distance is going to be awesome.
We have someone asking what was the overlap in this job. Did you said well you're a big fan of 70/70, but like what was the overlap in this one?
Yeah, so the overlap, I really just consider it based on what I'm looking at. So let's see if I can find it here. Think I start. So it looks like I tried to do 80 and 75. So I went for a little
Okay.
bit more overlap than I usually do. The reason for that is that while this building is well lit, there's no shine, there's a very few shiny surfaces. The problem that I saw coming was that what you're looking at is very similar across pictures, right? The facade is basically just a copy paste of windows across. So when the photogrammetry engine is looking for features that are unique, it might actually get confused because so many things are actually very similar in the
Yeah.
real world.
Yeah.
Yeah, so I went for a little bit more.
And sorry if I'm going ahead of getting ahead of myself, but like when you process this in the photogrammetry software, do you process the different facades and then combine them all, or do you load all of the flights and then process all of that together? How do you handle this on the photogrammetry software?
Yeah, it's a good question. I'll show you that in the other screen when we switch
Cool.
over to the data
Perfect.
here. So if you want to switch me over to the desktop that I have,
Yeah.
I'll get started
Here
on
it is.
explaining that.
Um,
Okay, we're good.
yeah.
Cool.
Is
Okay.
it working? Yeah.
Yeah,
There we
we're
go.
good. Okay, so in terms of the photos that I use, so this is just the scan folder that comes off of the Skydio after the 3D scan is complete.
Mm-hmm.
And so the first thing I do is I generally just look them over. So you can see in some of these photos these little green markers, and
Mm-hmm.
that's where my ground controls were. So you may have seen ground controls as targets or as reflective things. Really, all you need to do is to be able to find that point. And as well as sort of finding the center of that point. So what I use is this high visibility spray paint, and I make sure that I spray it completely vertical, so it's just a circular blob, and then I get the GPS position right in the center of that marker.
Okay, cool.
So I
Um,
yep.
can I just mention you were using Skydio 2 Plus? Sorry, I just saw a comment passing by. You were using Skydio 2 Plus for this mission?
Yeah, I was using
Okay.
a S2 Plus. Actually, I think I was using an S2. That was before I had the S2
Oh,
Plus. Yeah. So the nice thing about this kind of work is that you're really not that far away from the drone at all times. The S2 Plus has a lot better range compared to the S2, but I never had any problems with the S2 here because it's right there. It's just at the top, a few hundred feet away from me.
yeah.
So it worked really, really well. And the images, the lighting, it was great, and you can see the overlap that's happening beside all of these images. So I'm really happy with this. And then another thing that I always check is the metadata. So is there GPS information with this photo that's saved within the photo? So you can do that just by clicking on the info or details. But seeing this map here and this point on a map reassures me that there is additional information with this photo and it's stored within the photo itself, the metadata.
So tell us more about the metadata. So that's you go into the Windows folder, right click, go to properties, and that's
Mhm.
the EXIF data. So additional data that comes with the picture. Um,
Right. So right click properties and then go to
mhm.
details. And what you'll see here is a whole bunch of information about this. I don't know if it's clear enough on your screen, but what I see and the things that I'm looking for to make sure are here is the camera model. So right here it says Skydio 2 plus. Oh, I guess it was a 2 plus. It shows me the capture settings. So the ISO, the shutter speed. And then ultimately under GPS, I see a latitude and I see a longitude and an
Yeah.
altitude. So I'm happy if I have all of those things there.
Yeah, and then for most photogrammetry software, these will be automatically loaded. And even, for example, in context capture, we have a definition of a the camera calibration details. So you don't need to worry about uploading these. Once you input your data, context capture automatically identifies this is coming from Skydio 2 Plus, and
Mhm.
this is the camera details like focal length and things like that. So
Yeah. Yeah.
no need to worry about that. However, for Pix4D, for example, we do use a different file, which
Mhm.
is automatically generated in the folder directory together with your images. So it's something called like pics for the can't remember the name, but it's a CSV file, and you need to input that in the photogrammetry software.
Yeah, so here I have it on the screen. Here is context capture, just the first screen where you add the photos, and you can see that
Mm-hmm.
right away it picked up the 3000 photos. It says camera, it's recognized it's a 2 plus. It's got the sensor size and the focal length and the equivalent. So those are
Exactly.
like lens information details that you need to have, and the closer to the actual facts, the better. You need to have those to succeed in the alignment phase. That it really
Exactly.
helps to have that, and generally all the major drones, all the major cameras, they have this information baked into that picture, and then the software picks it up, regardless if it's context capture, Pix4D, what have you.
Yeah, 100%. And once you basically, this is a like it works kind of like the same in most photogrammetry platforms. So you input the data, and automatically you should be able to see that's coming from Skydio 2 plus or whatever it is.
Mhm.
If you don't know how to do these steps, there is a blog post on the Skydio website to help you go through that workflow for context capture, reality capture, Pix4D, and some other software platforms. So go to the website skydio.com, and in the blog post you will find that. In the blog you will find a post with that step-by-step workflow.
Yeah, it's a really good resource. And essentially, what that data that's in that image is doing for us is this is the first part of that workflow, right? So we're trying to align. This is even before alignment. And you can see these red dots and then these blue squares or blue crosses. The red dots are just being the location for each of these pictures, which is represented by these dots, is just being collected from that metadata. So you can see
Mm-hmm.
how they are already sort of aligned for us. But the one thing that we're missing is orientation. So that's
Mm-hmm.
part of this next alignment phase, and it's super duper important. So um, it always really just works the same way in this part.
Yeah.
In terms of the blue crosses, so those represent the ground control points. So where you saw those little green blobs, the GPS location that was collected with the rover, when I bring it into the software, it denotes it as that blue mark. So here I'm confident that my GPS and my photos, they're all in the same coordinate system. Everything is going to work well for me in the next few steps.
Do you want to just be mindful of the time because we're half an hour in? Do you want to start talking about the control points since we mentioned them, or will we
Yeah.
wait?
No,
Yeah.
let's dive right in it. So once we do that first alignments phase, I'm doing this in Pix4D here just to give you guys a sort of an overview of it. What you
Mm-hmm.
see here is a combination of things. It looks like kind of a mess here, but the blue dots represent where those pictures started. So where the metadata in the photo told the software it was. And then
Mm-hmm.
the green dots represent where the software actually calibrated that camera to. In this example, don't be worried about this if this ever happens to you. If you see these large differences between where it started and where it was calibrated, especially if it's in the vertical, that generally means we were using different vertical datums between these two data sets. So that's the case here. The images coming from the drone come from the GPS WGS84 vertical datum, and then what I was using
You
because we're looking.
recalibrate. Mm-hmm.
Exactly. So
Yeah.
it's not a concern, but really what we're looking at here is that Pix4D has figured out where the cameras were and then where they should be calibrated to.
Yeah.
And yep, go ahead.
And so the influence of control points in this process is massive. Like basically, if you don't have that control points in your data set, which is absolutely fine if you're just looking for relative accuracy.
Hmm.
So let's talk about that difference between relative accuracy and absolute accuracy. If you have like control points, basically you're pushing all your data, all your photogrammetry data to be aligned to
Hmm.
your control points. So that information, which typically is comes with like survey grade accuracy. So you are in between, 1 to 5 centimeter accuracy. So you're pushing all your data to be basically aligned to whichever information is coming from the control points. So that's why those differences are so large in this case. If
That
you,
that's
oh,
right.
sorry.
Yeah, I was going to say that without control points, you're generally still going to get very good
Yeah.
accuracy if the images are good. The control points are the cherry on top. They really tighten things up, and they also give you a way to verify your work. So without the control points, there's no
Exactly.
way for you to really know unless you went out and measured it with a ruler.
Mhm.
Control points can also be used just to verify that what you did is correct.
Exactly. And so if you are not using control points, your relative accuracy will still be very, very good. But you don't have to use spatial accuracy. So let's put an example. If you are measuring coordinates on your 3D model,
Mhm.
if you are doing that on your on a data set that has no control points, probably that coordinate will be, off by, I don't know, like give me like maybe 40 centimeter, maybe like half, like it depends on how um
Yeah, it's the Wild West. It
it's a
really can
wild west.
depend. There's so many different factors that go into it. So it is what it is when you don't
It
use
is what
control
it is,
points.
but you don't need it because normally, for example, if you're doing volume calculations, you don't need to know where that stockpile is in the world. What you actually are looking is how accurate that volume calculation is.
Hmm.
So that's when resolution comes in the conversation, because the resolution basically, that's the information that you capture in your pixel.
Hmm.
So when your ground sample distance, so that's the pixel size, is like, for example, 2 millimeter versus like 20 millimeter, then you're going to be much more precise when you do measure that on your computer. You measure that volume calculation, you are being much more precise because the information is much more visible in the pixel. Am
Hmm.
I
Yeah.
explaining this?
Yeah, I think you're on the money. So with this example, I use control points in the areas of sort of most extreme elevation change. So I did
Mm-hmm.
control points on the roof and then control points at the base of the building. Had I
Yeah,
done control points just on the roof, which would have been easy, I wouldn't have been able to verify the heights to be correct. So there may be
yeah,
maybe some compression or maybe some stretching out of the building in terms of elevation. So by doing them at top and bottom, that's a best practice. Same with bridges. We should probably always talk about control points and bridges being at the top of the bridge and something at the bottom. If you're
at the
only doing
bottom.
them at the
Yeah,
top, you're kind of only getting half of the benefits of the
yeah,
controls.
100%.
Right.
And another constraint that we can use these days with most photogrammetry software, correct me here if I'm wrong, Ted, you have more
Mhm.
experience than me, is the scale constraint. So if you do not have access to ground control points, you can also scale your data set by having those scale constraints. So if I know that this pillar is like 10-meter high, for example,
Mhm.
or I know, like some distances within my data, then you can input that into the software, and then you can have that scale constraint in your data set.
Yeah, exactly. So, scale constraints, a great way to do just the scale if that's all you're worried about is measurements.
Yeah,
Just do a scale constraint. It's
we fit
gonna
into
effectively give you the same results. But if you also want to know where it is in the world, which way it's rotated, then you need to do controls.
control points.
And so what we're zoomed in on here is a representation of that error that we've calculated through these controls. So these little pixels or these little squares, what those represents is we call those automatic tie points. So those are the
Mm-hmm.
locations across images that the software automatically found and then triangulated and put in this 3D space. The green cone represents my control point. So that's the coordinate that I told it, this is where it is. The blue cone represents the where it was calculated without my constraint. So, and then that green line that connects the two represents the error. So that error is
Yeah,
in 3D. It can be up, down, in all different directions. And sort of the length of that line is the magnitude of that error. So where my software or Pix4D in this case thought that point was going to be in relation to my marker is actually shown right in these images, right? So what I did is I clicked on that automatic tie point and I look now on the other hand of my screen here, and you'll see these images appear, and then you also see this target. So that is essentially where the software thought that point or that coordinate would be, and then that target is actually where it was. And if we click on the green pylon, you'll see that it's right on the target. So this is the difference between sort of the accuracy that you might be choosing to forego it. Sometimes it can be very small like this, and I have to really zoom in to even see it. Sometimes it can be pretty
Sometimes,
large.
yeah, yeah.
So that also depends on the images themselves as well.
And this process goes really quickly these days. Like as soon as you measure like a couple of pictures, it automatically just helps you to. It's just like a refinement basically
Hmm.
on that position that you need to do. So it's a very quick process.
Yeah, absolutely. So when we're talking about precision versus accuracy, so let's
Hmm.
take this example of this 3D GCP. So we have the accuracy, which really just depends on how accurate my GPS observation was.
Yeah,
So there is a factor, a contributing factor to error. So that's a little bit of out of our control sometimes, but generally we can affect it. And then there's the accuracy of our model. But then when we're talking about precision, we're talking about as we're zooming in, is
how
that
good you are.
yeah, like these are all pixels, right? So
Yeah,
our GSD dictates how much space these pixels occupy in the world. Um, our accuracy is just a point. Where that point is in the world, with a GSD like you have here, we can put it anywhere on the screen, but is it here right in the middle of this pixel? Is it a little bit off to the side? That's our sort of smallest unit of measurement. So when you hear
yeah.
GSD, think precision. That's sort of the smallest unit of measurement. It's not your accuracy. It doesn't, those two things are, believe it or not, completely different in a lot of cases.
They are, and so and also like something that I want to emphasize is like if you have a accuracy, geospatial accuracy of like 3 centimeters, for example, in your
Mhm.
control points, your accuracy in the final 3D model or point cloud is never going to be better than that. Never ever, because that is dependent. You are actually pushing all your data to the absolute accuracy of your control points. Now, the resolution, as you are showing here, is like it's going to help you to be more precise as you measure those points in your pixels,
Mhm.
because if you have like a 5 millimeter ground sample distance will be much more precise than a 15 millimeter ground sample distance. That's
Yeah. And
yeah,
so and ground sampling distance, we should also say, is really dependent on the view, right? So in this example here, we're looking at it top down. So everything in this, every pixel should be about that ground sampling distance. But
yeah,
when we're looking at a picture that's oblique, right, things start to change, right? This isn't as close as something that's over here. Sorry, this is much
a very good
further
point.
away, right?
Yeah,
So your ground sampling distance here isn't uniform across the image. Now, this isn't generally an issue when we're dealing with surveying and top-down imagery, but when we get into 3D scans like this one, it's one of those things that you need to understand. It's not one uniform number across your entire screen.
yeah, and you also need to be picky when you choose the pictures where you are going to be measuring your tie points and your control points, because that might increase like the error that you will get in your measurements,
Hmm.
because of what you just explained. So you also need to be mindful of those errors that you are introducing by measuring your control points or your tie points in pictures where the pixel is not as visible, or the pixel is not as good, or the precision might not be as good as in
Right.
other pictures. Yeah.
Right. So that's it essentially. We've got our controls, we've got our alignments, we're looking pretty good, and then we go into the next step, which is to densify, and then to mesh and create
Hmm.
that sweet 3D model that we're used to seeing. Here's an example of what a dense cloud looks like, right? So this is that bridge example. I've done the alignment. I'm happy with it. I've done my controls. I'm happy with those. My accuracy is good. And then I go into the next step, the densification, and this is the result of that densification. So what you'll see is that it looks solid from afar, but as we zoom in, you'll see that it's
Point
really
cloud.
just a fine point cloud. And make these a little bit bigger. You can see them sort of starting to appear. And now this is what we're going to use to extract line work like this.
So you use you're actually just generated densified point clouds. You haven't even textured that point cloud.
Uh,
And
yeah, you don't really need to. So the
yeah,
the nice thing about photogrammetry is that when you do get a point cloud out of photogrammetry, unlike laser scanning, each point also has with it the color value of that
Mm-hmm.
point, which can help you sort of look at what's going on.
Visualization, yeah.
Yeah, but it's not enough for like inspection or for measuring cracks or for that sort
Mm-hmm.
of thing. You really want to go to the textured mesh for that.
Yeah.
This is fantastic for extracting lines. So essentially what we're doing when we're extracting, we're looking at edges. And then we're clicking at specific locations on this point and drawing lines between those points.
And so what you do is importing the point cloud. Which format do you use?
So there's a lot of formats for point clouds. There's the proprietary ones. There's also like just general ones. The one that's most common is LAS, stands for
Mm-hmm.
laser. It's a pretty common one. Generally, everything will spit out an LAS if you ask it to, or default to that. So that's what I chose to use here. But the one thing that I want to say is that generally from photogrammetry, the point cloud that you get is usually too dense. Like there's just too many
Mm.
points. So my rule of thumb is I basically only need about 30% of the points that I got.
30%. Wow.
Mhm.
That's super interesting. So do you downsample that in Pix4D or any photogrammetry software, or how do you?
No, so I actually like to use Cloud Compare, which is what you're looking at
Yeah.
here. It's a totally free software. I think it's made by like one person. It's absolutely amazing, but it has a lot of tools. They're a little bit the learning curve's a little steeper, but it's very easy to pick up once you get what you're doing. And I just subsample here. So right here, I just tell it 30% of what I input. Give me that, and then I export that, and then I'm ready to start doing the line work, which is again what you see here. So there's no need for 100% of them. There's just too many, and it can also bog down your system when you're doing this line work. So it's just unnecessary. You can shed some of that precision. You're not losing accuracy, you're just losing a little bit of precision when you're doing that.
Yeah. Yeah. Yeah.
Mhm.
Good point.
Yeah, so Cloud Compare, I really recommend everybody goes out and picks it up and learns it. It's so powerful. You can do all kinds of different things on it, but ultimately, it's the images that matter, right? So if you have good images coming in, you're going to have good data like this going out. And then not all the software is the same. Some software will struggle with certain images, some software may not. And even how they pick the points can be different.
Question now. For this specific work, did you need geospatial accuracy? Because if you're doing line work, I will expect that as long as you have good enough relative accuracy, that will be enough.
Yeah. You know what? I did because we wanted to get accurate measurements out of this. I
Okay.
wanted to have both the geospatial accuracy in case of that I can come back and compare it the next year. But I also wanted to make sure that scale is done. So by taking ground control points from the structure, I'm able to achieve both, right? So very easily, what I did in this example with controls, and you can kind of see them here, is that I'll make this full screen, is I flew a pretty traditional 2D capture type of map over the bridge, and I used the same methodology of painting those little targets and just hanging my rover over the railing there and collecting it for a minute or so. And I had those control points, and I also did it on the banks of the river. So I don't know if you can see them in this image specifically, but on the other side, I did them on the ground. So I did top and ground, and I did them at intervals that were pretty similar. So here's another one. And the
Mm-hmm.
key here, especially for bridges, is that you're able to see this point. It's right at the corner, and you're able to see where that's marked from both the side and the top, and
Yeah.
then that's how you're going to tie everything together. Because if you put it inwards on the deck, you might not see it from the edge when you're flying your 3D scan.
Cool. And you're using Revit for the line work. Sorry, I'm just seeing a comment here.
Yeah, Revit is the big one. There's all kinds of different tools to use for line work. I'm not the line work expert. I always subcontract that, right? So that's like a lot of clicking in front of a computer screen, and it takes like a ton of practice to get really, really good at it. So I don't have the time to pick that up as well on top of everything else. So I send it to really good people that I've found on my network and give some suggestions. But
Mm-hmm.
they seem to use Revit quite a lot. So that's
Yeah.
what I've seen. But ultimately, all I'm giving them is that point cloud that was exported in that step that was then subsampled in Cloud Compare, and everything from then on is up to what you do on Revit to extract these lines and profiles.
Amazing. Thank you for that. We are 48 minutes in, Ted. If you wanna. there's anything, any points that we forgot to before we
Yeah.
start wrapping up.
Well, so if there's anybody in here that is generally new to photogrammetry and you're looking at sort of how to get started, what I would recommend is go and download Reality Capture. It's a fantastic app. It's got a little bit of a learning curve, but there's a lot of documentation out there on how to get started. The thing about Reality Capture is it's very affordable. So you don't actually have to pay anything unless you're exporting the data out. And
Hmm.
learning photogrammetry is a lot of trial and error. So reality capture gives you that benefit of being able to try different projects, try different scenes, put it into reality capture for free, do it on your own machine, and just keep doing that until you sort of learn what works and what doesn't. That's how I learned. And I really, really love reality capture. And beyond that, once you get a little bit more advanced, reality capture is really, really deep. You can do all kinds of stuff with it.
Mm.
Definitely all the stuff we talked about today: control, scale constraints, orthomosaics, and even mosaics off the side. You can do meshes. You can even combine laser scan data and photogrammetry together, which sort of gives you the ultimate deliverable.
Yeah.
So you can do all of that once you get more comfortable with it, and you really only have to pay if you want to export it out and send it to somebody else or do something else with it. So
I must admit the user interface is a bit overwhelming. Like even for myself, it's like, whoa, there's a lot going on here. But it's a very good point that it's a free software as long as you are testing in and you don't export any data. So it's actually a very good tip. I like this. I might do that too. I might get familiar with reality capture.
yeah, I mean, I,
Someday.
I I I always urge everybody to just try the same thing in different softwares and see how
Yeah.
how they change and sort of what they excel at, and then find the one you like the most, and then maybe commit to that one for commercial use.
Yeah. But when you don't
So
have the luxury like you and me of having like multiple licenses, it's a very good way to get familiar with the workflow and with the best practices without having to pay a massive amount of money.
yeah,
So
absolutely. And I
mhm.
agree with you. Like the UI in reality capture is kind of complex, but it's when you start to figure it out, it's really
Yeah.
not that bad. And it has a lot of sort of flexibility. So here I'm able to show four different things, but they all relate to the same area.
Mhm.
And sort of what you're seeing here as well, which I think is really cool, is the matches. So these green dots
Mhm.
are where the software found similar features across all of these images. So if you'd like to see even more detail about that, you can do this, show matches, and it'll start drawing these lines between them. And it really helps you understand like what's going on. If an area isn't working well, is it because I don't have matches? Is it because the image needs some retouching? Do I need control points to sort of help it align those things? It's really, really valuable to see it from this perspective, I think.
Mhm.
Yeah.
Cool. Yeah. Um, what else do we have in there before we wrap up? And we've missed something. Feel free to drop a comment with any requests for topics that we've we haven't addressed in the webinar today. Is there anything else, Ted, that we will
I'm just looking through some of these
comment?
comments. I see one says, "What about all of the other EXIF data, pan, tilt, roll of drone and gimbal? When will it be used in drone deploy?" I think you mean just in photogrammetry. So that's I think that's a good question. So what we get in that metadata from the drone is the position of the drone when the picture was taken. We also get some information about the angle of the gimbal and which direction the drone was facing. But just from the limitations of the sensors and the sort of the accuracy of what we get from that, we can't really trust those. So they give us an estimate, but really the photogrammetry software, what it's doing is it's figuring all of that stuff out with some high certainty, and it's using the overlap to mostly do that. So that's not something that we can just rely on right off of the drone. With LiDAR, we use much more complicated, much more accurate sensors because we're doing direct georeferencing, and that will be there. But with photogrammetry, it's very different, and we essentially can now use any camera, even if we don't have that information to align.
Cool. And there's another comment here. Can the photogrammetry engine handle multiple exposures of the same image? The
Uh,
same
i-
image.
So I think so multiple exposures, so like bracketing, I think maybe what they're referring to. So sort of the same position but multiple exposures. So
Mm,
so the answer is yes, it probably can. But generally you do not want to incorporate images that are from the same position and have different angles of view or orientation. That can trick things and make it a little bit more complicated for the software to handle. So as long as you're moving between exposures, then you should be fine. Photogrammetry kind of depends on that parallax effect when you're moving through a scene. So if you don't have that parallax effect, you can actually be creating more problems for yourself by bringing multiple images with different exposures from the same view. So
yeah,
answer is yes, but be careful.
yeah. Is there a way to incorporate PPK data with a Skydio level GPS?
So PPK is kind of another sort of more complex topic. So what it would say
Mm,
is PPK relies on very specific GPS receivers to be able to do that. So unless you're equipped with that, you're not going to be able to get the files and run post processing on those tags.
mm.
So the answer to that is it kind of depends on what you're doing and what you're using.
Yeah, that's fair enough. What are the best mesh formats that Reality Capture produces for use in visualization production? That's
Yeah,
a good
so
one.
reality capture is like really it's used by a lot of people in the production industry and the VFX
Hmm.
industry. So I guarantee you it supports almost everything you're going to want. The one that I use the most is actually what's called an OBJ. So for meshes, like I mentioned, there is the actual structure, the triangulated mesh, and then there's the texture as well that's wrapped around it. So those two things are generally stored separately. And I like OBJs because they've been around for a very long time, and they're very flexible around where you can import them. But if you have something more specific that you need, Reality Capture is probably going to be the one that's going to support it because they have so many users that are in that industry. I have
Yeah,
to say though that Context Capture also has a ton of exportable formats for the mesh, and again, I usually stick to OBJs, but there's a lot of options there.
yeah. Cool. Will we wrap up? Or is there anything else, Ted, that you want to tackle?
Well, there's again, as always, there's a lot that I want to tackle, but no, not every time you
That was
ask
a
me that
bad, that was
question.
that was a bad way to put it. Let's wrap up for today. We will be following up on all the comments we haven't addressed during the event. Ted and I will do that with yeah, we love doing that after the webinar. So feel free to reach out to us if you have any further questions. The webinar will be available in our YouTube channel, so I'll share that with everyone afterwards. And stay tuned for the next one. Who knows what will be? But I would love to do actually a live one from the field with you, Ted. So let's see if we can set that up. That might be a bit challenging, but I'm up for that challenge. Are you?
Yeah, it's going to be interesting. We'll do our best. I can't promise
We'll do
anything.
our best. Cool. Well, as always said, thank you so much, and thank you everyone for joining us today. And I'll see you very soon.
Awesome. Bye bye.
Bye. Thank you.